Representations of structural formulas. Today I'm here again with something new, something very interesting, and something very knowledgeable for all those who are the organic chemistry beginners, right? It's this lecture is most probably for the beginners level, because a few of the students, they come up to me with a few questions that they couldn't follow the structures of different type of structural formulas for different compounds. So I thought that I should give you some hints to them. This is for especially for those students. Okay, the structure number one is ball and stick model. That is, this one is ball and stick model, right? You now, why we call it a ball and stick model? Because you can see these are the black balls. These are the carbon atoms, and these are the yellow ones or white ones are the hydrogens. Whereas this one is a red one, is an oxygen that is connected to again a hydrogen by these single bonds. Now you can see all these, the connectivity of atoms. You can simply see these are connected by single bonds. So the rotations around the single bonds are relatively easy as compared to the double bonds. The rotations are difficult. So now here simply we call it a ball and stick model, because you can see the bonds that are connecting these carbons and hydrogens together along with this OH group by the sticks, right? These are the sticks and these are the balls. The black balls are the carbons, these are hydrogens, and the red one is an oxygen that is connected to again an hydrogen. So CH3, CH2, CH3, CH2, CH2OH, right? So this is the formula for propyl alcohol. Now you can simply write this formula again in the same form, again in another form, that is, we call it a dash formula. Now here simply it is the same thing as you have seen in the first one. Now, but now there is a difference. That is, these carbons, they are bonded to each other by again the dashes. You can see 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. All these dashes between the carbons and the hydrogens connecting one another in a straight chain with an oxygen and the electronic pairs around them and a hydrogen over there. So this is a dash formula. Whereas if we look at the third one, it is the condensed formula. And what is a condensed formula? This, now again you can see these are all the representations of different representations for different formulas. Now here simply you see that after this is CH3, CH2, CH2OH, the same one. The ball and stick model, the dash formula, and the condensed formula. The compound is the same, but have been written in 3 different forms up till now. So you can see an immediate carbon after methyl, an immediate carbon again, I mean an immediate carbon attachment after this this group, right? So the carbons are immediately attached in the condensed form without any dashes in between them, so we call it condensed forms. Okay, the fourth one is the bond line formula. And what is a bond line formula? It is simply, you can see a bonds, right, and lines. Now every corner represents a carbon atom. So again, this is the same thing, but this is, you can see condensed form, the bond line form, the dash form, and of course the ball and stick form. So now I have written few lines for you here. These are the structural formulas for isopropyl. We can also now write the dot structures. One more thing. These are the dot structures. Mostly we do not show the dot structures, but need to spare some time. So, but here I've written the dot one and the dash ones again, right? So these are all the forms for the same for different compounds. Now the organic chemists, they have the command to write or use number of ways to write structural formulas as shown here in the ball and stick model, right? And the dash formula and the condensed formula and the bond line, that is this one formula below. Acha. Okay, now the below, whereas below are the dot structures, right? Dot structures, they represents all the electrons of the valence shell, right? Now the valence shell, that is the outermost shell, the electrons, they are representing this one. But just to spare time, as I just mentioned before, that it's hectic, it's difficult, or it's tiresome to write down, all the so many dots to combine all these carbons and hydrogens together. We just avoid all that and we use the condensed forms. Sometimes we use the ball and stick model forms, or the straight dash forms, or the dash forms, right? So we just want to spare the time. So just because of that, we write the condensed forms. But when, of course, you are now as an organic chemist, so you will go through the organic reactions. So whenever you are encountering or you are doing an organic reactions, or you are showing or presenting an organic reactions, we do need to show the, or a proper reaction, you do need to share the unshared electron pairs that participate in the reactions, right? Because you have to show them the movement of those pairs, the electron pairs moving or departing from one source to and reaching to the other one, right, to the destinations, right? So we do need to we do need to write the unshared electron pairs that are participating in the reactions. Now here, if we see the ball and stick model, this one, that is again the first one, and of propyl alcohol, and compare it with the other two dash and condensed forms, that is this one dash forms and the condensed formulas, we can see that atoms connecting the chains are straight, whereas the model, that is this one, ball and stick model, it represents a 3D structure. Now this is a three-dimensional structure in which the rotation of bonds, that is the bonds are constantly rotating, right? The rotation of bonds is easily shown or easily represented when you use this formula, right? That is the ball and stick models. Okay, as it is a 3D structure, means three-dimensional structure, and all bonds can rotate. As it is also very important to note that all those atoms that are connected to each other by single bonds are easily rotatable. Now, as you simply see here that these bonds are all single bonds, so as compared to the double bonds, the single bonds are always easy to rotate. So this is also one of the reasons that we use these formulas, right? So I have now shown you again, I can explain you that the first one was ball and stick model, the dash formula, the condensed formula, and the bond line formula for the compound that is called propyl alcohol. And of course, I have shown after that the dot formulas and the dash formulas, right, of other compound, right? So these are all the things that can sum up, and they can give you some idea that how these structural formulas or can be represented in different ways for one compound. So one compound can be represented in all these different forms, by a ball and stick model, by a dash formula, by a condensed formula, or by a bond line formula. Okay, now here we see equivalent dash formulas for propyl alcohol. Now here are the three different formulas written for propyl alcohol. And you can see three different arrangements here. These equivalent structures are for propyl alcohol, as I just mentioned, and can have variety of number of different arrangements and are all equivalent. That is, having bond angles of 90 degrees with them. Okay, they actually present or make us follow the way atoms are connected to each other, the way these atoms are connected to each other. They are only showing us that thing, though not representing actual shapes. They only present connectivity having different structural formulas. So these three are showing us only the way the atoms are connected to each other. That is called the connectivity. Okay. So now here below, now let's move back to the second example, that is the equivalent dash isopropyl alcohol formulas. Okay, it is also called secondary alcohols. Okay, so now here below we have another example, that is isopropyl or secondary alcohol, which is colorless, flammable liquid, possesses very strong odor. This is a compound in which isopropyl is attached to an OH group. Okay, it has got a density of about 786 kilograms per cubic meter, whereas boiling point is almost about 82.5 degrees centigrade. Now it's a constitutional isomer. Now these are the constitutional isomers of propyl alcohol, that is having different connectivity and different structural formulas. Here atoms are linked with one another in different order. You can see the different order. The OH group is attached to the central carbon atom, but the order is different. Okay, now one thing to point out is that OH is attached to the central carbon atom. This is what I've mentioned just here. So that is position of OH group is different here, here, and there. You can see the position of OH group is different in propyl and isopropyl alcohols. In the above example also, and in the example, if you compare these two examples, you can see that the position of OH group was different for propyl alcohol and for isopropyl alcohol. Okay, now let's if we discuss the condensed formulas, that is the condensed, this one, the third one, the condensed formulas. The condensed structure formulas, they're very easy to write than the other forms like dash or dot ones. Now here what happens in condensed formulas, now the word itself explains itself, condense, okay, to squeeze down, okay, to make it more, precise, more closer, right? So in condensed formula, all the hydrogens connected to carbon are written straight away after the carbon listing hydrogens first. So this is the difference between the condensed formulas or the equivalent dash formulas or the equivalent dash formulas for propyl alcohol or for the secondary alcohols or isopropyl alcohol. So here I have explained you all these three different ways to follow the three different arrangement of atoms, right, around the carbons. So carbon atoms around this. So this was something interesting, and I hope you have followed, and you have you will definitely learn from these, and this would be helpful in getting knowledge about how to write the structural formulas in different ways. And I think I've made it all clear. Now confusion will be clear, and you will be more clear now in your thoughts that how you are going to follow these different type of arrangements. Hope to see you again with another new and something more interesting and exciting, with something new which would be helpful to you. Please do learn from these lectures, because they are all from your courseworks, and you are supposed to learn these basic lectures, basic topics with great concentration. Thank you very much.